sleep study.
Close your eyes and imagine floating in the vast emptiness of space. The silence is absolute. The darkness stretches endlessly in every direction. And somewhere in that infinite void, things exist that would make your worst nightmares seem like bedtime stories. Tonight, we're going to explore the most terrifying facts about deep space, the kind that will make you question everything you thought you knew about the universe we call home. What you're about to hear isn't science fiction. These aren't stories designed to entertain you. These are documented realities discovered by our most advanced telescopes and confirmed by the world's leading astrophysicists. Facts so disturbing that they fundamentally change how we see our place in the cosmos. Facts that reveal just how fragile, how temporary, and how utterly insignificant our entire existence really is. You might think you're prepared for what's coming. You might believe you understand the scale of the universe, the dangers lurking in the darkness between stars. But what if I told you that right now, as you listen to these words, something is hurtling toward us at millions of miles per hour? Something that could end everything we've ever known, loved, or built. Something that wouldn't just destroy Earth, but would obliterate every trace that we ever existed. The universe is not the peaceful, orderly place we once imagined. It's a violent, chaotic realm where entire solar systems are torn apart by forces beyond comprehension, where black holes devour light itself, where gamma-ray bursts unleash more energy in seconds than our sun will produce in its entire lifetime. And the most terrifying part, we're completely helpless against any of it. Tonight, I'm going to take you on a journey through the darkest corners of space. We'll explore cosmic phenomena so extreme they challenge the very laws of physics. We'll discover how the universe is actively trying to kill us in ways you've never imagined. And we'll uncover the disturbing truth about what awaits us in the far distant future, when the last star dies and the cosmos itself begins to decay. But before we dive into the abyss, let me tell you why these facts matter. Understanding the true nature of space isn't just about satisfying curiosity. It's about confronting the reality of our situation. We live on a tiny rock, orbiting an average star, in an unremarkable galaxy, surrounded by forces that could erase us without warning. Yet somehow, in the face of this cosmic horror, we continue to exist. We continue to love, to create, to hope. And perhaps that's the most remarkable thing of all. The first thing you need to understand is that space is not empty. This might seem obvious, but the implications are far more sinister than you realize. What we call empty space is actually seething with quantum fluctuations, virtual particles popping in and out of existence, and fields of energy that could, under the right conditions, tear apart the fabric of reality itself. The vacuum of space is unstable, and that instability could be our doom. Consider this. There's a theoretical possibility that our entire universe exists in what's called a false vacuum. Think of it like a ball balanced on a hill. It seems stable, but it's actually in a precarious position. If something nudges it just right, it will roll down to a lower energy state. If our universe is in a false vacuum, a quantum fluctuation could trigger a collapse that would rewrite the laws of physics as it expands outward at the speed of light. We wouldn't see it coming. One moment everything would be normal, the next moment reality itself would cease to exist. But that's just the beginning. Let's talk about something called vacuum decay. Imagine a bubble of destruction expanding through space, consuming everything in its path. Inside this bubble, atoms can't form. Matter as we know it cannot exist. It's not just death, it's the complete erasure of the possibility of existence. And the most terrifying part, it might already be happening. Somewhere in the distant reaches of space, a bubble of vacuum decay could be racing toward us right now, and we would never know until it arrived. The darkness between stars isn't just empty space. It's filled with rogue planets, massive worlds that were ejected from their solar systems and now wander through the void. These cosmic nomads are completely invisible, detectable only when they pass in front of a star or bend light with their gravity. There could be billions of them out there, including some that might be heading directly toward our solar system. A rogue planet the size of Jupiter could disrupt the orbits of all the planets, sending Earth spiraling into the sun or flinging it out into the frozen depths of space. Even more disturbing are the rogue black holes. These invisible monsters roam through space, their gravity so intense that they warp the fabric of space-time itself. A black hole doesn't need to hit Earth to destroy us. If one passed close enough to our solar system, it could stretch and compress our planet through tidal forces, literally pulling it apart. The gravitational effects would be felt long before the black hole arrived, causing earthquakes, tsunamis, and atmospheric disruption that would make the surface uninhabitable. But perhaps the most insidious threat comes from something called dark matter. This mysterious substance makes up about 85% of all matter in the universe, yet we can't see it, touch it, or directly detect it. We only know it exists because of its gravitational effects on visible matter. Dark matter is everywhere, passing through your body right now, and we have no idea what it's capable of. Some theories suggest that dark matter could interact with ordinary matter in ways we don't understand, potentially causing the protons in our atoms to decay. If this happened, every atom in your body would simply disintegrate. The scale of destruction in space is beyond human comprehension. Consider magnetars, neutron stars with magnetic fields trillions of times stronger than Earth's. These cosmic monsters are so magnetic that they can strip the electrons from atoms at a distance of 600 miles. If a magnetar were located where our moon is, it would erase every credit card on Earth and probably kill us all through radiation. The magnetic field is so intense that it warps the very atoms that make up the star's surface, creating a landscape of crystalline structures harder than diamond. When these magnetars experience what's called a starquake, they release more energy in 1/10 of a second than our sun produces in 100,000 years. The electromagnetic pulse from such an event can be detected from thousands of light years away. In 2004, a magnetar called SGR 1806-20 released a gamma-ray burst that reached Earth and temporarily blinded several satellites. If that magnetar had been just 10 light years away instead of 50,000, the radiation would have stripped away our ozone layer and sterilized the surface of our planet. The most violent events in the universe are gamma-ray bursts, explosions so powerful they can be seen from billions of light years away. These cosmic catastrophes occur when massive stars collapse into black holes, or when neutron stars collide. For a brief moment, a single gamma-ray burst can outshine an entire galaxy containing hundreds of billions of stars. The energy release is so intense that it focuses into narrow beams, like cosmic lighthouses of destruction. If a gamma-ray burst occurred within 6,000 light years of Earth and was pointed in our direction, it would be game over for life on our planet. The initial burst would last only seconds, but it would dump more energy into our atmosphere than our sun provides in years. The radiation would destroy the ozone layer, causing a mass extinction as ultraviolet light from the sun sterilized the surface. The burst would also create nitrogen oxides in the atmosphere, leading to acid rain and climate change that could last for decades. What makes this particularly terrifying is that we might not see it coming. The light from the gamma-ray burst travels at the same speed as the deadly radiation. There would be no warning, no time to prepare. One moment you'd be going about your day, and the next moment the sky would light up brighter than the sun. Within hours, the effects would begin. Plants would start dying. Animals would develop radiation sickness. And slowly, over the course of months or years, the ecosystems that sustain life on Earth would collapse. The Milky Way galaxy, our cosmic home, is on a collision course with the Andromeda galaxy. In approximately 4.5 billion years, these two massive spiral galaxies will merge in a cosmic dance of destruction. While the individual stars are unlikely to collide due to the vast distances between them, the gravitational forces will completely reshape both galaxies. Our solar system could be flung out into intergalactic space, where the night sky would be nearly empty of stars. But long before that cosmic collision, our own sun will begin its death throes. As it runs out of hydrogen fuel, it will expand into a red giant, growing so large that it will engulf Mercury, Venus, and possibly Earth. The surface temperature of our planet will rise to thousands of degrees, boiling away the oceans and stripping away the atmosphere. Even if Earth somehow survives being swallowed by the sun, it will be left as a charred, lifeless rock orbiting a white dwarf star. The death of stars is not peaceful. When a star more than 8 times the mass of our sun reaches the end of its life, it explodes in a supernova, releasing more energy in seconds than our sun will produce in its entire 10 billion year lifetime. The explosion is so violent that it can be seen from billions of light years away. The shockwave travels through space at thousands of miles per second, and if it hits a planet, it can strip away the atmosphere and sterilize the surface. Even more extreme are hypernovae, explosions that are 100 times more powerful than regular supernovae. These cosmic catastrophes occur when the most massive stars collapse into black holes. The energy release is so intense that it creates jets of material traveling at nearly the speed of light. These jets can remain active for minutes or even hours, continuously pumping out deadly radiation across vast distances. The universe is filled with structures so large they challenge our understanding of physics. Take the Boötes void, a region of space so empty that it's been called the Great Nothing. This cosmic bubble is 330 million light-years across and contains almost no galaxies. If the Milky Way were located in the center of the Boötes void, we wouldn't have discovered other galaxies until the 1960s. The void is so large that light from one side takes longer to reach the other side than the entire age of the universe. But even more disturbing are the cosmic web filaments, vast structures made of dark matter that connect galaxy clusters across billions of light years. These filaments are like the skeleton of the universe, invisible threads that determine where galaxies form and how they move. We're essentially living inside a cosmic web that we can't see, controlled by forces we don't understand. The most massive structures in the universe are galaxy clusters, groups of hundreds or thousands of galaxies bound together by gravity. These clusters are so massive that they warp space-time itself, creating gravitational lenses that bend and distort the light from more distant galaxies. The gravity is so intense that it heats the space between galaxies to millions of degrees, creating a plasma so hot it glows with X-rays. When galaxy clusters collide, the results are catastrophic on a cosmic scale. The collision creates shock waves that travel through the cluster at thousands of miles per second, heating the intergalactic medium to temperatures of hundreds of millions of degrees. These collisions can trigger the formation of new stars and galaxies, but they can also destroy existing ones, stripping away their gas and leaving them as stellar graveyards. The expansion of the universe itself is accelerating, driven by a mysterious force called dark energy. This means that galaxies are moving away from each other at ever-increasing speeds. Eventually, the expansion will become so rapid that it will overcome all other forces in the universe. First, galaxy clusters will be torn apart. Then, individual galaxies will be isolated. Finally, even atoms themselves will be ripped apart in what's called the Big Rip. If dark energy continues to accelerate the expansion of the universe, we're heading toward a future where space itself expands faster than the speed of light. This doesn't violate relativity, because space itself is expanding, not matter moving through space. But the consequences are terrifying. About 22 billion years from now, the Milky Way will be torn apart. The solar system will be disrupted. Earth will be separated from the sun. And finally, about 10 to the minus 32 seconds before the Big Rip, every atom in the universe will be torn apart. But even if we avoid the Big Rip, the long-term future of the universe is bleak. The process of star formation will eventually stop as the universe runs out of the gas and dust needed to create new stars. The last stars will burn out, leaving behind only black holes, neutron stars, and brown dwarfs. The universe will enter what's called the degenerate era, a time when only these stellar remnants remain. As time passes, even these remnants will decay. Protons, the building blocks of atoms, may not be stable forever. If they decay, then everything made of matter will eventually disintegrate. The universe will be left with only electrons, positrons, neutrinos, and photons scattered across an ever-expanding cosmic void. The final fate of the universe may be the heat death, a state where entropy has reached its maximum and no more work can be done. The temperature will approach absolute zero, and the universe will be a cold, dark, empty place where nothing interesting can ever happen again. It's a future so distant that the human mind can barely comprehend it. But it's the ultimate destination of everything we know and love. Yet even in this cosmic nightmare, there are phenomena that defy our understanding of what's possible. Hidden in the depths of space are objects so strange, so alien to our experience, that they challenge the very foundations of physics. These aren't just theoretical constructs or mathematical curiosities. They're real, they're out there, and they're doing things that should be impossible. Consider the cosmic phenomenon known as quasars. These are supermassive black holes that are actively feeding, consuming matter at such a rate that they outshine entire galaxies. The energy output is so immense that a single quasar can be seen from billions of light years away, appearing as a brilliant point of light in the darkness. But here's what makes them truly terrifying. The jets of material they shoot out can extend for millions of light years, moving at nearly the speed of light. These jets are like cosmic flamethrowers, streams of plasma and radiation that can sterilize entire regions of space. If our galaxy were in the path of a quasar jet, the radiation would strip away our atmosphere and cook the surface of every planet in our solar system. The energy would be so intense that it would break apart the molecular bonds that hold matter together, reducing everything to its component atoms. But quasars are just the beginning. Deep in the heart of our own galaxy lurks something even more sinister, Sagittarius A, a supermassive black hole 4 million times the mass of our Sun. This monster sits quietly at the center of the Milky Way, slowly consuming any matter that ventures too close. We can't see it directly, but we can observe its effects on the stars that orbit around it. These stars, some of the most massive in our galaxy, are whipped around the black hole at speeds of up to 7,000 kilometers per second. The gravitational forces are so intense that time itself slows down near the black hole. If you could somehow survive a journey to its vicinity, you would age more slowly than people on Earth. But survival would be impossible. The tidal forces would stretch your body like taffy long before you reached the event horizon. The event horizon itself is perhaps the most terrifying boundary in the universe. It's the point of no return, the distance from a black hole where the escape velocity equals the speed of light. Once you cross this threshold, there's no coming back. You would fall toward the center of the black hole, being stretched and compressed by tidal forces until you're reduced to a stream of subatomic particles. and from the perspective of someone watching from a safe distance, you would appear to slow down and freeze at the event horizon. Your image redshifted and dimmed until it fades from view. But what happens at the center of a black hole, the singularity, is even more disturbing. Here, the laws of physics break down completely. Matter is compressed to infinite density, and space-time itself becomes infinitely curved. It's a place where our understanding of reality simply stops working. The singularity isn't just a point of extreme gravity, it's a tear in the fabric of existence itself. Some physicists theorize that black holes might be connected by wormholes, tunnels through space-time, that could potentially allow travel between distant regions of the universe. But these wormholes, if they exist, would be incredibly unstable. The slightest disturbance would cause them to collapse, and any attempt to travel through one would likely result in being crushed by the intense gravitational forces. The space between galaxies isn't empty either. It's filled with something called the intergalactic medium, a thin soup of gas and plasma that's been heated to millions of degrees by the radiation from stars and black holes. This medium is so hot that it glows with X-rays, creating a faint background glow that permeates the entire universe. But within this medium lurk dangers that could threaten entire civilizations. Massive shock waves travel through the intergalactic medium, created by the collision of galaxy clusters or the explosion of supernova. These shock waves can span millions of light years and move at speeds of thousands of kilometers per second. When they encounter a galaxy, they can strip away its gas and dust, preventing new stars from forming and essentially sterilizing the galaxy over cosmic time. The cosmic web that connects galaxies is also home to something called dark matter streams. These are rivers of invisible matter that flow through space, following the gravitational currents of the cosmic web. We don't know what dark matter is made of, but we know it's there because of its gravitational effects. These streams could carry unknown dangers, particles or forces that could interact with ordinary matter in ways we can't predict. Some of the most violent events in the universe occur when neutron stars collide. These incredibly dense objects, with more mass than our Sun, packed into a sphere only 20 kilometers across, can spiral into each other over millions of years. When they finally merge, the collision creates a kilonova, an explosion that forges heavy elements like gold and platinum, while simultaneously creating gravitational waves that ripple through space-time itself. The gravitational waves from such collisions travel at the speed of light, carrying information about the most extreme events in the universe. When they pass through Earth, they stretch and compress space itself by distances smaller than the width of a proton. We've only recently developed the technology to detect these waves, and what we're discovering is that the universe is far more violent and chaotic than we ever imagined. But perhaps the most unsettling aspect of space is its sheer indifference to our existence. The universe doesn't care about life, about consciousness, about the civilizations that might arise on countless worlds. It operates according to physical laws that are utterly neutral, creating and destroying with equal ease. A gamma-ray burst that could sterilize our planet is just the natural consequence of a massive star's death. The collision of our galaxy with Andromeda is simply the inevitable result of gravitational attraction. This indifference extends to the very structure of matter itself. The protons in our atoms, the building blocks of everything we know, may not be stable forever. Some theories suggest that protons can decay, with a half-life so long that it makes the current age of the universe seem like an instant. If protons decay, then every atom in your body, every molecule in every living thing will eventually disintegrate. The process would take an unimaginably long time, but it would be inevitable. The uncertainty principle of quantum mechanics adds another layer of cosmic horror. At the smallest scales, the universe is fundamentally uncertain. Particles can exist in multiple states simultaneously, until they're observed. This quantum uncertainty is built into the fabric of reality itself. It means that the universe is not deterministic, it's probabilistic. Events happen based on chance, and even with perfect knowledge of the present, we could never predict the future with absolute certainty. This quantum uncertainty also allows for the possibility of virtual particles, pairs of particles and antiparticles that spontaneously appear and disappear in the vacuum of space. These virtual particles are constantly popping into existence and annihilating each other, creating a seething foam of activity in what we think of as empty space. But under extreme conditions, these virtual particles can become real, contributing to phenomena like Hawking radiation from black holes. The concept of Hawking radiation reveals another disturbing truth about the universe. Even black holes, the most permanent seeming objects in the cosmos, eventually evaporate. As they emit radiation, they slowly lose mass and shrink. The smaller they get, the faster they evaporate, until they finally disappear in a burst of energy. This process takes an incredibly long time for stellar mass black holes, but it's inevitable. Even the supermassive black holes at the centers of galaxies will eventually evaporate, leaving behind only elementary particles and radiation. The vacuum of space itself might be unstable. Quantum field theory suggests that the vacuum is filled with quantum fields that exist in their lowest energy state. But what if this isn't actually the lowest possible energy state? What if our vacuum is metastable, like a ball balanced on a hill? A quantum fluctuation could cause it to roll down to a lower energy state, creating a bubble of true vacuum that expands at the speed of light, destroying everything in its path. This vacuum decay would be the ultimate cosmic catastrophe. Inside the bubble of true vacuum, the laws of physics would be different. Atoms might not be able to form, or they might have different properties. The fundamental forces that hold matter together could be altered. It wouldn't just be the end of life, it would be the end of reality as we know it. The possibility of vacuum decay highlights one of the most terrifying aspects of our cosmic situation. We might be living in a universe that's fundamentally unstable. Every moment that passes without a vacuum decay event is, in a sense, borrowed time. We exist in a brief window of stability in an otherwise chaotic and dangerous cosmos. But even if we avoid vacuum decay, the heat death of the universe awaits us in the far future. As entropy increases and the universe continues to expand, the temperature will gradually approach absolute zero. Stars will burn out, black holes will evaporate, and eventually, even the protons in atoms will decay. The universe will become a cold, dark, empty place where nothing interesting can ever happen again. This is the ultimate fate that awaits everything we know and love. All of human civilization, all of our art and culture, all of our scientific achievements will be forgotten in the vast emptiness of a dead universe. It's a future so distant that it's almost meaningless to contemplate, but it's the inevitable destination of everything that exists. The scale of this cosmic horror is beyond human comprehension. We live for decades, maybe a century if we're lucky, but the universe operates on timescales of billions or trillions of years. The events that will shape the ultimate fate of the cosmos are already set in motion, grinding forward with the inevitability of physical law. We're like mayflies, contemplating the movement of continents, utterly insignificant in the face of cosmic time. Yet somehow, in the face of all this cosmic terror, life persists. On at least one small planet orbiting an ordinary star, matter has organized itself into complex patterns that can think, feel, and contemplate the universe that created them. We are the universe becoming aware of itself, if only for a brief moment in cosmic time. The very fact that we can understand these cosmic horrors, that we can peer into the depths of space and time and comprehend the forces that govern reality, is perhaps the most remarkable thing of all. We are made of star stuff, forged in the nuclear furnaces of dying stars, and we carry within us the capacity to understand our own origins and our ultimate fate. This understanding comes at a price. The more we learn about the universe, the more we realize how precarious our existence truly is. Consider the delicate balance that allows life to exist on Earth. Our planet orbits at just the right distance from the Sun, in what astronomers call the habitable zone. Too close, and we'd be like Venus, with surface temperatures hot enough to melt lead. Too far, and we'd be a frozen wasteland like Mars. But this Goldilocks zone isn't permanent. As our sun ages and gradually grows brighter, the habitable zone is slowly moving outward. In about 1 billion years, Earth will be too hot to support liquid water on its surface. The oceans will boil away, and our planet will become another Venus, shrouded in thick clouds of water vapor and carbon dioxide. The atmosphere that protects us is itself incredibly fragile. It's held in place by Earth's gravity, but it's constantly being eroded by solar wind, the stream of charged particles flowing from the Sun. Mars once had a thick atmosphere, but it lost most of it to space because the planet's magnetic field is too weak to deflect the solar wind. Earth's magnetic field protects us, but it's not permanent either. Our planet's magnetic field is generated by the motion of molten iron in Earth's core. This process creates a protective bubble around our planet that deflects most of the harmful radiation from space. But the magnetic field isn't stable. It fluctuates in strength and occasionally reverses completely, with the magnetic north and south poles switching places. During these reversals, which happen every few 100,000 years, the magnetic field weakens dramatically. The last reversal occurred about 780,000 years ago, which means we're overdue for another one. Some scientists believe we might already be in the early stages of a reversal, as the magnetic field has been weakening over the past 150 years. If the field collapsed completely, even temporarily, the consequences would be catastrophic. The atmosphere would be stripped away by solar wind, and the surface would be bombarded by deadly cosmic radiation. But even our Sun, the source of all life on Earth, is not the stable, reliable star we imagine it to be. Solar flares, massive explosions on the Sun's surface, can hurl billions of tons of charged particles into space at speeds of millions of miles per hour. When these particles interact with Earth's magnetic field, they create beautiful auroras. But a sufficiently powerful solar flare could overwhelm our magnetic defenses. The largest solar flare in recorded history occurred in 1859, an event known as the Carrington event. Telegraph lines sparked and caught fire, and auroras were visible as far south as the Caribbean. If a similar event occurred today, it would destroy our electrical grid, knock out satellites, and cripple our technology-dependent civilization. The economic damage would be measured in trillions of dollars, and it could take decades to fully recover. But the Carrington event was nothing compared to what the Sun is capable of. Superflares, events hundreds of times more powerful than anything we've recorded, have been observed on other stars similar to our Sun. These events are rare, occurring perhaps once every few thousand years, but they're not impossible. A superflare from our Sun would strip away Earth's ozone layer and sterilize the surface with ultraviolet radiation. The Sun itself is slowly dying. It's about halfway through its main sequence lifetime, steadily converting hydrogen into helium in its core. As it does so, it gradually grows brighter and hotter. This process is so slow that it's imperceptible on human timescales, but it's relentless. In about 5 billion years, the Sun will exhaust the hydrogen in its core and begin to expand into a red giant star. This expansion will be catastrophic for the inner planets. Mercury will be completely vaporized. Venus will be engulfed by the sun's outer atmosphere. Earth might survive being swallowed, but it will be heated to temperatures of thousands of degrees. The oceans will boil away, the atmosphere will be stripped off, and our planet will become a charred cinder orbiting a dying star. Even if somehow life managed to survive the sun's red giant phase, the final stages of stellar evolution would be even more destructive. The sun will eventually shed its outer layers, creating a planetary nebula before collapsing into a white dwarf star. This white dwarf will be incredibly hot initially, but it will slowly cool over trillions of years, eventually becoming a cold, dark stellar remnant. The death of our sun is just one small part of a much larger cosmic apocalypse. All stars have finite lifetimes, and the universe is slowly running out of the raw materials needed to form new ones. The process of star formation requires vast clouds of gas and dust, but these clouds are gradually being consumed or dispersed. Eventually, no new stars will be born, and the universe will be left with only the slowly dying remnants of the last generation of stars. This stellar death sentence affects not just our solar system, but every planetary system in the galaxy. Countless worlds that might harbor life will be sterilized as their stars die. Entire civilizations, if they exist, will be forced to confront the same inevitable fate that awaits us. The universe is not just indifferent to life, it's actively hostile to it. The space between stars is not the peaceful void we imagine. It's filled with cosmic rays, high-energy particles that travel at nearly the speed of light. These particles are created by supernovae, black holes, and other violent cosmic events. They constantly bombard our planet, but most are deflected by our magnetic field or absorbed by our atmosphere. However, if we ever venture far from Earth, these cosmic rays will pose a serious threat to human health. Long-term exposure to cosmic radiation can cause cancer, genetic damage, and neurological problems. Astronauts on missions to Mars would be exposed to levels of radiation hundreds of times higher than what we experience on Earth. The particles can pass through spacecraft hulls and spacesuits, making it nearly impossible to provide adequate protection. This radiation is one of the major obstacles to human exploration of deep space. But cosmic rays are more than just a health hazard for space travelers. They can also affect our planet's climate. When cosmic rays interact with Earth's atmosphere, they create ions that can serve as nucleation sites for cloud formation. Changes in the cosmic ray flux, caused by variations in solar activity or our passage through different regions of the galaxy, might influence Earth's weather patterns over long timescales. Our solar system is currently traveling through a relatively empty region of space called the local bubble, a cavity in the interstellar medium that was blown out by ancient supernova. This region has a low density of gas and dust, which reduces the amount of cosmic radiation we're exposed to. But in about 50,000 years, we'll exit the local bubble and enter a denser region of space. The increased cosmic ray flux could affect our climate and increase the mutation rate in all living organisms. The galaxy itself is not a stable, unchanging structure. It's a dynamic system where stars are constantly being born and dying, where massive black holes lurk at the center, and where violent events regularly reshape entire regions of space. Our solar system orbits the galactic center once every 225 million years, a journey that takes us through different neighborhoods of the galaxy, each with its own unique dangers. As we orbit the galaxy, we periodically pass through the spiral arms, regions of higher stellar density where star formation is active. These regions are dangerous because they contain massive, short-lived stars that explode as supernovae. The increased rate of stellar explosions in the spiral arms could expose Earth to more frequent gamma-ray bursts and cosmic ray bombardment. Some scientists have proposed that our passage through the spiral arms might be correlated with mass extinction events in Earth's history. The theory suggests that the increased cosmic radiation and climate disruption caused by nearby supernovae could trigger the collapse of ecosystems and the extinction of species. While this connection is still debated, it highlights how our position in the galaxy affects the habitability of our planet. The center of our galaxy is particularly dangerous. Sagittarius A, the supermassive black hole at the galactic core, is surrounded by a dense cluster of stars, many of which are massive and short-lived. This region experiences frequent supernova, stellar collisions, and other violent events. The radiation levels near the galactic center are so high that complex life as we know it probably couldn't survive there. But even our current position in the galaxy's outer regions isn't completely safe. The galactic halo, the spherical region that surrounds the galactic disk, contains ancient stars and globular clusters that occasionally pass through our neighborhood. These objects can gravitationally disturb the Oort cloud, the spherical shell of comets that surrounds our solar system, at a distance of about 1 light-year. When the Oort cloud is disturbed, it can send a shower of comets toward the inner solar system. These comets can collide with planets, potentially causing mass extinctions. The impact that killed the dinosaurs 66 million years ago might have been caused by such a comet shower. The cycle of comet impacts appears to occur roughly every 26 million years, possibly correlated with our solar system's oscillation above and below the galactic plane. The entire galaxy is also on a collision course with its nearest large neighbor, the Andromeda Galaxy. This collision, which will occur in about 4.5 billion years, will completely reshape both galaxies. While individual stars are unlikely to collide due to the vast distances between them, the gravitational disruption will scatter star systems throughout the merged galaxy. Our solar system could be flung into intergalactic space, where the night sky would be nearly empty and the temperature would be close to absolute zero. But even if we avoid being ejected from the galaxy, the merger will trigger a period of intense star formation and stellar collisions. The supermassive black holes at the centers of both galaxies will spiral toward each other, creating gravitational waves and eventually merging into an even larger black hole. This process will release enormous amounts of energy, potentially sterilizing large regions of the merged galaxy. The collision with Andromeda is just one example of how the universe is constantly evolving and changing. Galaxy mergers are common throughout the cosmos, and they're one of the primary ways that large galaxies like our own were formed. Each merger is a catastrophic event that can destroy existing planetary systems and create new ones. The history of the universe is written in these cosmic collisions, each one reshaping the structure of space and time. The dark matter that makes up most of the universe's mass is also in constant motion, forming vast structures that dwarf individual galaxies. These dark matter halos determine where galaxies form and how they evolve. We're embedded in one of these halos, invisible to our senses, but controlling the motion of every star in our galaxy. The dark matter particles are passing through our bodies right now, and we have no idea what they're doing to us. Some theories suggest that dark matter might decay or annihilate, producing high-energy particles that could affect living organisms. Other theories propose that dark matter might clump together to form dense objects that could disrupt planetary orbits or cause other gravitational effects. The truth is, we know so little about dark matter that we can't rule out almost any possibility. The expansion of the universe itself is accelerating, driven by the mysterious dark energy that makes up about 70% of the universe's energy density. This acceleration means that distant galaxies are moving away from us at ever-increasing speeds. Eventually, they'll be moving so fast that their light will be redshifted beyond the visible spectrum, and they'll effectively disappear from our observable universe. This cosmic expansion is stretching the wavelengths of light. making the universe colder and darker with each passing moment. The cosmic microwave background radiation, the afterglow of the Big Bang, is being stretched to longer and longer wavelengths. Eventually, this radiation will be redshifted so far that it will effectively disappear, leaving the universe in complete darkness. The acceleration of cosmic expansion also means that the universe is becoming less dense over time. The average distance between galaxies is increasing, and eventually, each galaxy will be alone in its own expanding bubble of space. The night sky will gradually become emptier as distant galaxies fade from view. Future civilizations will have no way of knowing that other galaxies exist, and they'll be forced to conclude that they're alone in the universe. This cosmic isolation is already beginning. The most distant galaxies we can observe are moving away from us at speeds approaching the speed of light. Their light is being stretched and dimmed by the expansion of space. In a few billion years, these galaxies will have moved so far away that their light will no longer be able to reach us. They'll have crossed the cosmic horizon, disappearing from our observable universe forever. The ultimate fate of the universe depends on the nature of dark energy. If it continues to accelerate the expansion, we're heading toward a future called the Big Rip, where space itself expands so rapidly that it tears apart all matter. First, galaxy clusters will be disrupted. Then individual galaxies will be torn apart. Eventually, even atoms themselves will be ripped apart by the expanding fabric of space. The Big Rip would occur in about 22 billion years if dark energy continues to accelerate at its current rate. But even if we avoid this fate, the long-term future of the universe is still bleak. As stars burn out and black holes evaporate, the universe will enter a phase called the heat death, where entropy reaches its maximum and no more work can be done. The temperature will approach absolute zero, and the universe will become a cold, dark, empty place where nothing interesting can ever happen again. This is the ultimate destiny that awaits everything we know and love. All of human civilization, all of our achievements and dreams will be forgotten in the vast emptiness of a dead universe. It's a future so distant that it's almost meaningless to contemplate. But it's the inevitable conclusion of the physical laws that govern reality. Yet despite this cosmic horror, despite the countless ways the universe is trying to kill us, we continue to exist. We continue to love, to create, to explore, and to hope. We are the universe becoming aware of itself, and in that awareness, we find meaning, even in the face of ultimate meaninglessness. We are stardust contemplating the stars, temporary patterns of matter and energy that have somehow learned to think and feel and wonder about their place in the cosmos. The darkness of space is not just physical, it's existential. It represents the vast unknown that surrounds us, the questions we may never answer, and the ultimate fate that awaits all things. But it's also beautiful in its own terrifying way. It's the canvas on which the drama of existence is painted, the stage on which the cosmic dance of creation and destruction plays out across billions of years. As you drift off to sleep tonight, remember that you are part of this cosmic story. You are made of elements forged in the hearts of dying stars, and you carry within you the capacity to understand and appreciate the universe that created you. The cosmic horror that surrounds us is real, but so is the wonder and beauty that can be found in even the darkest corners of space. The universe may be vast and indifferent, but it's also filled with mysteries waiting to be solved, wonders waiting to be discovered, and possibilities that we can barely imagine. In the face of cosmic horror, we find not just fear, but also awe, curiosity, and the unshakable human desire to understand our place in the grand scheme of things. The silence of space isn't truly silent. It's filled with something far more disturbing than sound could ever be. Radio waves carry the death screams of civilizations across the galaxy, electromagnetic pulses from stellar explosions that happened millions of years ago, and signals from objects so alien that our instruments can barely detect them. These cosmic whispers tell stories of destruction on a scale that makes our worst nightmares seem like children's bedtime stories. Consider the phenomenon known as fast radio bursts, or FRBs. These are intense pulses of radio waves that last only milliseconds, but release more energy than our sun produces in an entire day. They come from distant galaxies, billions of light years away, and we have no idea what causes them. Some theories suggest they're the result of neutron star collisions. Others propose they're created by black holes tearing apart matter at the speed of light. But the most disturbing possibility is that they're artificial, signals from civilizations far more advanced than our own. If FRBs are indeed artificial, what does that tell us about the universe? It suggests that there are beings out there with technology so advanced they can manipulate neutron stars, harness the power of black holes, or create energy bursts that outshine entire galaxies. The very existence of such beings would render humanity utterly insignificant, like bacteria contemplating the actions of gods. But perhaps even more terrifying is the possibility that FRBs are natural phenomena, the universe's way of announcing the death of something unimaginably vast and complex. Each burst might represent the final moment of a stellar system, the collapse of a cosmic structure, or the end of a process that took billions of years to unfold. We're receiving these signals like cosmic death certificates, notifications of destruction that occurred when the universe was young and our solar system didn't even exist. The radio spectrum is filled with other disturbing signals as well. Pulsars, rapidly rotating neutron stars, sweep beams of radiation across space like cosmic lighthouses. These beams are so precise that they can be used as clocks, more accurate than any timepiece ever built by humans. But their regularity is also unsettling, a mechanical heartbeat from objects that shouldn't exist. Stars compressed to densities so extreme that a teaspoon of their matter would weigh as much as a mountain. When pulsars were first discovered in 1967, astronomers initially thought they might be signals from extraterrestrial civilizations. The pulses were so regular and artificial sounding that they were labeled LGM-1 for little green men. But the reality turned out to be far stranger than any alien civilization. These signals were coming from the remnants of massive stars that had exploded in supernovae, leaving behind objects so dense that their gravity warped space-time itself. The fact that nature can create objects more precise than any machine we've ever built is deeply unsettling. It suggests that the universe operates according to principles we don't fully understand, that there are forces at work that can create order from chaos on a scale that dwarfs human comprehension. The precision of pulsars is not comforting. It's mechanical, alien, and utterly indifferent to our existence. Some pulsars are even more disturbing. Millisecond pulsars rotate hundreds of times per second, spinning so fast that they should tear themselves apart. The fact that they remain stable defies our understanding of how matter behaves under extreme conditions. These objects are like cosmic dynamos, generating magnetic fields trillions of times stronger than Earth's, fields so intense they can strip electrons from atoms at vast distances. The electromagnetic radiation from these objects creates invisible storms in space, regions where the very fabric of reality is twisted and distorted. If Earth were to pass through one of these storms, the radiation would overwhelm our magnetic field and atmosphere, sterilizing the surface and destroying the ozone layer. The charged particles would interact with our atmosphere to create auroras so bright they would be visible during the day, beautiful but deadly displays of our planet's destruction. But pulsars are not the only sources of dangerous radiation in space. The galaxy is filled with cosmic ray accelerators, objects that can boost particles to energies far beyond anything we can create in our most powerful particle accelerators. These cosmic rays travel through space at nearly the speed of light, carrying energies that can penetrate any shield we might construct. When cosmic rays interact with Earth's atmosphere, they create cascades of secondary particles that rain down on the surface. Most of these particles are harmless, but some can cause genetic mutations or disrupt electronic systems. The constant bombardment of cosmic rays is one of the reasons why life on Earth has such a high mutation rate, driving evolution, but also causing cancer and genetic disorders. The sources of the highest energy cosmic rays remain a mystery. These particles carry so much energy that they shouldn't be able to exist according to our current understanding of physics. They're called the oh my god particles, and they hit Earth's atmosphere with the energy of a baseball traveling at 60 miles per hour, all concentrated in a single subatomic particle. The fact that such particles exist suggests that there are processes in the universe far more violent than anything we've ever imagined. Some scientists theorize that these ultra-high energy cosmic rays might be created by black holes that are actively feeding, accelerating matter to impossible speeds before flinging it out into space. Others suggest they might be the result of exotic physics, particles created by the decay of dark matter or the collision of cosmic strings. The truth is, we don't know what creates these particles, and that ignorance is itself terrifying. The space between galaxies is not empty either. It's filled with what astronomers call the warm-hot intergalactic medium, a tenuous soup of gas heated to temperatures of millions of degrees. This medium is so hot that it glows with X-rays, creating a faint background radiation that permeates the entire universe. The gas is kept at these extreme temperatures by the energy released from black holes and supernovae, a constant rain of destruction that prevents the universe from cooling down. This intergalactic medium is also threaded with magnetic fields, invisible lines of force that can channel cosmic rays and other high-energy particles across vast distances. These fields are created by the motion of charged particles in the hot gas, and they can become tangled and twisted by the gravitational effects of galaxies and galaxy clusters. When these magnetic field lines reconnect, they release enormous amounts of energy, creating magnetic storms that can affect entire regions of space. The structure of the universe itself is held together by dark matter, an invisible substance that makes up most of the mass in the cosmos. This dark matter forms vast networks of filaments that connect galaxies across billions of light years, creating what astronomers call the cosmic web. We can't see this web directly, but we can infer its existence from the way galaxies are distributed through space. The cosmic web is not static, it's constantly evolving, with dark matter streams flowing along the filaments, carrying galaxies and galaxy clusters with them. Our own galaxy is part of this cosmic dance, moving through space at hundreds of kilometers per second as it follows the gravitational currents of the dark matter web. We're not just orbiting the center of the Milky Way. We're part of a much larger structure that's flowing through the universe at incredible speeds. The dark matter itself remains one of the greatest mysteries in physics. We know it exists because of its gravitational effects, but we don't know what it's made of or how it interacts with ordinary matter. Some theories suggest that dark matter particles might be their own antiparticles, annihilating when they collide and producing bursts of gamma rays. If this is true, then the dark matter halo surrounding our galaxy might be glowing with deadly radiation, invisible to our eyes, but potentially lethal to any life that ventures too far from Earth. Other theories propose that dark matter might decay over time, slowly breaking down into lighter particles and releasing energy in the process. This decay would be incredibly slow, taking place over timescales longer than the current age of the universe, but it would be inevitable. If dark matter decays, then the structure of the universe itself is temporary, destined to collapse as the invisible scaffolding that holds galaxies together gradually crumbles away. The possibility of dark matter decay raises disturbing questions about the long-term stability of the universe. If the dark matter halos that surround galaxies begin to evaporate, the galaxies themselves might be torn apart by their own rotation. Stars would be flung out into intergalactic space, and planetary systems would be disrupted by the changing gravitational field. The night sky would gradually become emptier as stars disappeared into the void. But even if dark matter is stable, the universe faces other long-term threats. The accelerating expansion of space, driven by dark energy, means that the cosmic web is being stretched and weakened over time. The filaments of dark matter that connect galaxies are becoming thinner and more tenuous, and eventually they might snap entirely. When this happens, galaxies will become isolated islands in an ever-expanding sea of empty space. The isolation of galaxies would mark the beginning of the end for cosmic evolution. Without the gravitational influence of neighboring galaxies, star formation would slow down and eventually stop. The gas and dust needed to create new stars would be gradually consumed or expelled, leaving behind only the slowly dying remnants of the last generation of stars. The universe would enter what cosmologists call the degenerate era, a time when only white dwarfs, neutron stars, and black holes remain. This cosmic isolation is already beginning in some regions of the universe. The expansion of space is carrying distant galaxies away from us at ever-increasing speeds, and their light is being stretched and dimmed by the Doppler effect. Eventually, these galaxies will move so far away that their light will be redshifted beyond the visible spectrum, effectively disappearing from our observable universe. Future civilizations will have no way of knowing that other galaxies exist, and they'll be forced to conclude that they're alone in an empty cosmos. The accelerating expansion of the universe is one of the most disturbing discoveries in modern cosmology. It suggests that the universe is not just expanding, but that the expansion is getting faster over time. This acceleration is driven by dark energy, a mysterious force that makes up about 70% of the universe's energy density. We don't know what dark energy is or why it exists, but we know it's there because of its effects on the expansion of space. If dark energy continues to accelerate the expansion of the universe, we're heading toward a future called the Big Rip. In this scenario, the expansion of space becomes so rapid that it overcomes all other forces in the universe. First, galaxy clusters will be torn apart as the space between galaxies expands faster than their gravity can hold them together. Then, individual galaxies will be disrupted as the space between stars expands beyond their gravitational reach. The Big Rip would occur in about 22 billion years if dark energy continues to accelerate at its current rate. But the destruction wouldn't stop there. As the expansion continues to accelerate, even smaller structures would be torn apart. The solar system would be disrupted as the space between planets expands beyond the reach of the sun's gravity. Eventually, even atoms themselves would be ripped apart as the space between protons and electrons expands faster than the electromagnetic force can hold them together. The final moments before the Big Rip would be apocalyptic. The expansion of space would become so violent that it would tear apart the fabric of reality itself. Space-time would be stretched and distorted beyond recognition, and the laws of physics would break down completely. It would be the ultimate end of everything, not just the destruction of matter and energy, but the annihilation of the very concepts of space and time. But even if we avoid the Big Rip, the long-term future of the universe is still bleak. The second law of thermodynamics guarantees that entropy will continue to increase, and the universe will gradually become more disordered and less capable of supporting complex structures. Stars will burn out, black holes will evaporate, and eventually, even protons might decay, leaving behind only a thin soup of elementary particles and radiation. This heat death of the universe would occur over timescales so vast that they're almost meaningless to contemplate. But it's the inevitable destination of everything we know and love. All of human civilization, all of our achievements and dreams will be forgotten in the vast emptiness of a dead universe. The very atoms that make up our bodies will be scattered across the cosmos, their bonds broken by the relentless march of entropy. The concept of entropy itself is deeply unsettling. It's the measure of disorder in a system, and it always increases over time. This means that the universe is constantly becoming more chaotic and less organized. The complex structures that we see around us, from galaxies to living organisms, are temporary islands of order in a sea of increasing chaos. They exist only because the universe is still young and has not yet reached its maximum entropy state. The increase of entropy is what gives time its direction. Without entropy, there would be no difference between past and future, no reason for events to unfold in a particular sequence. The arrow of time is driven by the inexorable increase of disorder, and it points toward a future of maximum chaos and minimum information. This is why the universe appears to be running down, like a clock that's slowly winding down toward its final tick. The realization that the universe is mortal, that it has a finite lifespan and will eventually die, is one of the most profound and disturbing discoveries in human history. It means that everything we do, everything we create, everything we care about is ultimately temporary. The universe itself is not eternal. It's a brief flicker of order in an infinite sea of chaos, destined to fade away like a candle in the wind. Yet despite this cosmic horror, despite the countless ways the universe is trying to kill us and the inevitable fate that awaits all things, we continue to exist. We continue to love, to create, to explore, and to hope. We are the universe becoming aware of itself, and in that awareness, we find meaning even in the face of ultimate meaninglessness. We are patterns of matter and energy that have somehow learned to think and feel and wonder about their place in the cosmos. The darkness of space is not just physical, it's existential. It represents the vast unknown that surrounds us, the questions we may never answer, and the ultimate fate that awaits all things. But it's also beautiful in its own terrifying way. It's the canvas on which the drama of existence is painted, the stage on which the cosmic dance of creation and destruction plays out across billions of years. The radio telescopes that listen to the cosmos are picking up signals from events that happened billions of years ago, messages from a universe that was young and violent and full of possibilities. These signals carry information about the birth and death of stars, the collision of galaxies, and the evolution of cosmic structures on scales that dwarf human comprehension. They're like letters from the past, written in the language of electromagnetic radiation and delivered across the vast emptiness of space. But some of these signals are more disturbing than others. The cosmic microwave background radiation, the afterglow of the Big Bang, carries within it the imprint of quantum fluctuations that existed when the universe was less than a second old. These fluctuations are so small that they can barely be detected, but they're the seeds from which all the structure in the universe grew. The fact that such tiny variations could grow into galaxies, stars, and planets is both remarkable and terrifying. The cosmic microwave background also reveals that the universe is not perfectly uniform. There are regions that are slightly denser than average and regions that are slightly less dense. These variations are the result of quantum fluctuations in the early universe, random events that occurred when the cosmos was smaller than an atom. The fact that the large-scale structure of the universe is based on quantum randomness is deeply unsettling, suggesting that chaos and uncertainty are built into the very fabric of reality. The study of the cosmic microwave background has also revealed that the universe is flat, meaning that parallel lines will never meet and the angles of triangles always add up to 180 degrees. This flatness is not a coincidence. It's the result of a period of rapid expansion called cosmic inflation that occurred in the first fraction of a second after the Big Bang. During this inflation, the universe expanded by a factor of at least 10^26, smoothing out any irregularities and creating the flat, uniform cosmos we observe today. But cosmic inflation also creates disturbing implications. If inflation occurred once, it could occur again, and in fact, it might be occurring right now in distant regions of space. This process of eternal inflation would create an infinite number of universes, each with its own physical laws and constants. In this multiverse, every possible outcome would be realized somewhere, including universes where the laws of physics are so different that matter cannot exist. The multiverse hypothesis suggests that our universe is just one bubble in an infinite foam of realities, each one expanding and evolving according to its own rules. Some of these universes might be similar to ours, with stars, planets, and perhaps even life. Others might be so alien that we couldn't even recognize them as universes at all. The fact that we exist in a universe that's capable of supporting life might be nothing more than a cosmic accident, a random fluctuation in an infinite sea of possibilities. This realization is both liberating and terrifying. It means that our universe is not special, that the laws of physics that govern our reality are not fundamental truths, but random selections from an infinite menu of possibilities. It also means that somewhere in the multiverse, there might be universes where the laws of physics are actively hostile to life, where the very existence of consciousness is impossible. The concept of the multiverse also raises disturbing questions about the nature of reality itself. If there are infinite universes, then every possible event must occur somewhere. There are universes where you made different choices, where history unfolded differently, where the laws of physics are subtly altered. In some of these universes, you might be living a completely different life, while in others, you might never have existed at all. The implications of the multiverse are so vast that they challenge our understanding of meaning and purpose. If everything that can happen does happen somewhere, then what makes our choices significant? Are we just actors in a cosmic play, reading lines that have been written by the random fluctuations of quantum fields? Or do we have genuine agency, the ability to shape our own destiny, even in the face of infinite possibilities? These questions have no easy answers, and perhaps that's the point. The universe is not obligated to make sense to us, to provide us with meaning or purpose, or even comprehensible laws of physics. We are temporary patterns in an infinite ocean of chaos, brief moments of consciousness in an otherwise unconscious cosmos. The fact that we can contemplate our own existence, that we can wonder about our place in the universe, might be the most remarkable thing of all. The darkness of space surrounds us, vast and empty, and filled with dangers we can barely imagine. But it's also filled with wonders, with phenomena so strange and beautiful that they challenge our understanding of what's possible. The universe is not just trying to kill us, it's also creating us, nurturing us, and providing us with the raw materials for consciousness and wonder and love. As you drift towards sleep, remember that you are part of this cosmic story. You are made of elements forged in the hearts of dying stars, and you carry within you the capacity to understand and appreciate the universe that created you. The cosmic horror that surrounds us is real, but so is the beauty and wonder that can be found in even the darkest corners of space. In the silence between heartbeats, in the pause between thoughts, the universe continues its ancient dance of creation and destruction, and somehow, impossibly, we are here to witness it. The most disturbing aspect of our cosmic predicament isn't the violence or the scale of destruction. It's the realization that we might not be alone in facing these horrors. Scattered throughout the galaxy are the remnants of civilizations that came before us, silent monuments to species that once looked up at their own night sky with the same wonder and terror we feel today. These dead worlds tell stories more frightening than any horror film. Planets where the atmosphere has been stripped away by their dying sun, leaving behind crystallized cities exposed to the vacuum of space. Worlds where the oceans have boiled away, revealing the fossilized remains of creatures that once swam in alien seas. Archaeological sites buried under kilometers of ice, marking the graves of civilizations that thrived for millions of years before their star expanded and snuffed them out. The most chilling discovery is that many of these civilizations were far more advanced than we are. They had technologies that could manipulate matter at the atomic level, harness the power of their stars, and even bend space-time itself. Yet none of that advancement saved them. The universe consumed them just as indifferently as it will consume us, reducing their greatest achievements to cosmic dust. Some of these dead civilizations left behind warnings, messages encoded in the very structure of matter itself, designed to survive the death of their worlds. These messages speak of cosmic threats we haven't even discovered yet, dangers that exist on scales so vast that our current understanding of physics breaks down completely. They tell of entities that exist in the spaces between dimensions, feeding on the energy of dying universes. They warn of cascade failures in the fabric of reality itself, where the collapse of one universe triggers the destruction of countless others. But perhaps the most disturbing messages are the ones that speak of inevitability. These civilizations, despite their advanced understanding of the cosmos, came to the same conclusion that haunts our own scientists: that the universe is designed for destruction, not creation. That entropy isn't just a physical law, but a fundamental principle that governs all existence. That consciousness itself might be nothing more than a temporary glitch in the cosmic program. A brief moment of self-awareness before the universe returns to its natural state of chaos. The concept of the Great Filter looms over these discoveries like a cosmic sword of Damocles. This theoretical barrier represents the point in a civilization's development where they either transcend their limitations and survive, or fail and go extinct. The silence of the galaxy suggests that most civilizations never make it past this filter. They either destroy themselves through war, environmental collapse, or technological disaster, or they're destroyed by external forces beyond their control. The terrifying question is whether we've already passed the Great Filter, or if it still lies ahead of us. If we've passed it, then we might be one of the few species in the galaxy to survive this long, making us incredibly rare and precious. But if the filter is still ahead of us, then our current existence is just the calm before the storm, the brief moment of stability before we encounter the cosmic test that will determine whether our species survives or joins the countless others in extinction. The evidence suggests that the filter might be multifaceted, a series of increasingly difficult challenges that civilizations must overcome. The development of nuclear weapons represents one potential filter, as species that develop this technology might destroy themselves before they can reach the stars. Climate change represents another, as civilizations that can't learn to live in harmony with their environment might render their planets uninhabitable. But there are other filters that we haven't even considered yet. The development of artificial intelligence might represent a filter, as species that create machines smarter than themselves might be replaced or destroyed by their own creations. The discovery of certain fundamental truths about the universe might represent a filter, as civilizations that learn too much about the nature of reality might lose the will to continue existing. The cosmic microwave background radiation carries within it subtle patterns that some scientists believe might be evidence of other universes colliding with our own. These collisions would leave circular patterns in the radiation, like ripples on a pond. If these patterns are real, they suggest that our universe is just one bubble in an infinite foam of realities, constantly colliding and merging and splitting apart. The implications of universe collisions are staggering. When two universes collide, their different physical laws would interact in ways that we can't predict. The fundamental constants that govern our reality might be altered, causing atoms to behave differently or forces to change their strength. The collision might create regions of space where the laws of physics are so distorted that matter cannot exist, or where time flows backward, or where cause and effect are reversed. These cosmic collisions might be happening right now in regions of space so distant that their effects haven't reached us yet. But when they do, the consequences would be catastrophic. The wave of altered physics would travel through space at the speed of light, rewriting the laws of reality as it passed. Stars would behave differently. Planets would be torn apart by changed gravitational forces, and life as we know it would be impossible. The concept of vacuum metastability adds another layer of cosmic horror to our existence. The quantum fields that permeate all of space might exist in a false vacuum state, like a ball balanced on a hill. This state appears stable, but it's actually metastable, meaning that a small disturbance could cause it to collapse to a lower energy state. If this happened, it would create a bubble of true vacuum that would expand at the speed of light, destroying everything in its path. Inside this bubble of true vacuum, the laws of physics would be completely different. The forces that hold atoms together might be weaker or stronger, or they might not exist at all. The particles that make up matter might have different masses or charges, or they might decay into other particles. The very concept of matter and energy might be meaningless in this new physics. The expansion of the true vacuum bubble would be unstoppable. Once it started, nothing could prevent it from consuming the entire universe. We wouldn't see it coming because it would travel at the speed of light, arriving at the same time as the light that would warn us of its approach. One moment, everything would be normal, and the next moment, reality itself would cease to exist. The quantum fluctuations that constantly occur in empty space might be the trigger for such a collapse. These fluctuations are usually too small to have any macroscopic effects, but in certain extreme conditions, they might be amplified enough to cause the vacuum to collapse. High-energy particle collisions, the intense gravitational fields near black holes, or even certain types of cosmic rays might provide the energy needed to trigger this ultimate catastrophe. The possibility of vacuum collapse is not just theoretical. Particle physicists have calculated that the Higgs field, which gives mass to all particles, might exist in a metastable state. If this is true, then the collapse of the Higgs field could trigger the collapse of the entire vacuum, ending not just our universe, but all possible universes that share the same fundamental physics. The study of dark energy has revealed that the expansion of the universe is not just accelerating, but that the acceleration itself might be increasing. This suggests that dark energy is not a constant force, but something that grows stronger over time. If this trend continues, it could lead to a scenario even more catastrophic than the Big Rip. In this scenario, called the Little Rip, the acceleration of cosmic expansion would become so extreme that it would overcome all forces in the universe simultaneously. Unlike the Big Rip, which would tear apart structures in order from largest to smallest, the Little Rip would destroy everything at once. Galaxy clusters, galaxies, solar systems, planets, and atoms would all be torn apart at the same moment in a final instant of cosmic destruction. The timeline for the Little Rip would be much shorter than the Big Rip, possibly occurring in just a few billion years. This would mean that the universe has far less time remaining than we previously thought, and that the current era of cosmic evolution is already in its final stages. The stars that are forming today might be among the last stars that will ever exist, and the civilizations that might arise on planets orbiting these stars would have only a brief window of time before the universe itself is destroyed. The concept of cosmic inflation, which explains the large-scale structure of the universe, also contains disturbing implications for our future. If inflation occurred once, it could occur again, and in fact, it might be occurring right now in distant regions of space. This process of eternal inflation would create an infinite number of universes, each one expanding and evolving according to its own rules. But eternal inflation also means that our universe is not unique. Somewhere in the infinite expanse of the multiverse, there are exact copies of our universe, with identical copies of our galaxy, our solar system, and even ourselves. These duplicate universes would evolve in exactly the same way as ours, with the same history, the same events, and the same people living the same lives. The existence of infinite duplicate universes raises profound questions about the nature of identity and consciousness. If there are infinite copies of you living identical lives, which one is the real you? Are you all equally real? Or are you just one instance of a pattern that repeats endlessly throughout the multiverse? The very concept of individual identity becomes meaningless when faced with infinite duplication. But even more disturbing is the possibility that some of these duplicate universes might be slightly different from ours. Small quantum fluctuations during inflation could create universes where history unfolded differently, where you made different choices, where the laws of physics are subtly altered. In some of these universes, you might be living a completely different life, while in others, you might never have existed at all. The anthropic principle suggests that we can only observe a universe that's capable of supporting our existence. But this doesn't mean that our universe is special or designed for life. Instead, it might mean that we're living in one of the rare universes where the physical constants happen to align in a way that allows for the formation of stars, planets, and complex chemistry. The vast majority of universes in the multiverse might be empty, lifeless wastes, where the laws of physics prevent the formation of any interesting structures. This realization is both humbling and terrifying. It means that our existence is not the result of design or purpose, but of cosmic lottery. We won the ultimate jackpot by being born in a universe where life is possible. But this victory is meaningless because there are infinite other universes where we lost. Our universe is not special. It's just one random selection from an infinite menu of possibilities. The concept of Boltzmann brains adds another layer of existential horror to the multiverse. In an infinite universe with infinite time, random quantum fluctuations could occasionally assemble into complex structures, including brains capable of conscious thought. These Boltzmann brains would exist for only a brief moment before disintegrating, but during that moment, they would experience thoughts and sensations just as real as your own. The disturbing implication is that Boltzmann brains should be far more common than naturally evolved brains like ours. If the universe is infinite and eternal, then there should be countless Boltzmann brains for every naturally evolved brain. This means that you're more likely to be a Boltzmann brain, experiencing a brief moment of consciousness before dissolving back into the quantum foam, than you are to be a real person living in a real universe. The Boltzmann brain paradox challenges our understanding of consciousness and reality itself. If you can't distinguish between being a real person and being a Boltzmann brain, then what does it mean to be real? Are your memories of the past actually memories, or are they just random patterns that happen to form in your brain at the moment of its creation? Is the universe around you actually there, or is it just a hallucination created by a randomly assembled brain? These questions have no satisfactory answers, And perhaps that's the point. The universe is not obligated to make sense to us, to provide us with meaning or purpose, or even a coherent sense of reality. We are temporary patterns in an infinite ocean of chaos, brief moments of consciousness in an otherwise unconscious cosmos. The fact that we can contemplate our own existence, that we can wonder about our place in the universe, might be the most remarkable thing of all. The cosmic web that connects galaxies across billions of light years is not just a static structure. It's dynamic, constantly evolving as dark matter streams flow along the filaments and galaxies merge and separate. This web is also fragile, held together by gravitational forces that can be disrupted by the expansion of the universe or by the collision of massive structures. As the universe continues to expand and age, the cosmic web will gradually dissolve. The filaments that connect galaxies will become thinner and more tenuous, and eventually, they will snap entirely. When this happens, galaxies will become isolated islands in an ever-expanding sea of empty space. The night sky will gradually become emptier as distant galaxies fade from view, leaving behind only the slowly dying stars in our own galaxy. The dissolution of the cosmic web will mark the beginning of the end for cosmic evolution. Without the gravitational influence of the larger structure, galaxies will no longer interact with each other, and the processes that drive star formation and galactic evolution will slow down and eventually stop. The universe will enter a phase of cosmic senescence, where change becomes increasingly rare and the potential for new developments gradually diminishes. But even our own galaxy is not immune to the forces of cosmic destruction. The Milky Way is currently cannibalizing smaller galaxies, tearing them apart with its gravity and absorbing their stars. This process has been going on for billions of years, and it will continue until all the nearby galaxies have been consumed. The scars of these ancient collisions can still be seen in the stellar streams that wrap around our galaxy, ghostly reminders of the civilizations that might have once existed in those destroyed worlds. The future collision with the Andromeda Galaxy will be the most dramatic event in our galaxy's history. As the two galaxies approach each other, their gravitational interaction will trigger bursts of star formation and stellar collisions. The supermassive black holes at the centers of both galaxies will spiral toward each other, creating gravitational waves that will ripple through space-time. When they finally merge, the resulting black hole will be so massive that it will dominate the dynamics of the entire merged galaxy. The gravitational waves from this collision will carry information about the merger across the universe, announcing the death of two ancient galaxies and the birth of a new one. But this new galaxy will be different from its predecessors. A cosmic graveyard where the ordered spiral structure has been replaced by a chaotic, elliptical distribution of stars. The stellar nurseries where new stars are born will be disrupted, and the rate of star formation will gradually decline. The merger will also scatter many star systems into the intergalactic void. Our own solar system might be one of these refugees, flung out of the galaxy by the gravitational chaos of the collision. If this happens, the night sky will become almost completely dark, with only a few nearby stars visible to any civilizations that might still exist. The merged galaxy will appear as a faint smudge of light in the distance, a reminder of the cosmic home that was lost. The long-term evolution of the merged galaxy will be a slow decline toward darkness. As the universe continues to expand and cool, the conditions for star formation will become increasingly unfavorable. The gas and dust needed to create new stars will be gradually consumed or expelled from the galaxy, leaving behind only the slowly dying remnants of the last generation of stars. The final phase of galactic evolution will be dominated by stellar remnants, white dwarfs, neutron stars, and black holes. These objects will continue to interact gravitationally, occasionally colliding or merging to create brief flares of energy in an otherwise dark universe. But even these interactions will become increasingly rare as the objects spread out and lose energy through gravitational wave radiation. The ultimate fate of all matter in the universe might be to fall into black holes, which would then slowly evaporate through Hawking radiation. This process would take an unimaginably long time, longer than the current age of the universe, by factors of trillions of trillions. But it would be inevitable, the final victory of entropy over order, chaos over complexity. The evaporation of black holes would mark the end of the stelliferous era, the age of stars, and the beginning of the black hole era. During this time, the universe would be dominated by these invisible monsters, slowly consuming the last remnants of matter and energy. The temperature of the universe would approach absolute zero, and the only sources of energy would be the faint glow of Hawking radiation from the evaporating black holes. But even this era would eventually end. The smallest black holes would evaporate first, followed by progressively larger ones. The supermassive black holes at the centers of galaxies would be the last to go, taking trillions of years to completely evaporate. When the last black hole finally disappears, the universe would enter its final phase, the heat death. In this ultimate state, the universe would be a cold, dark, empty place where entropy has reached its maximum value. There would be no sources of energy, no gradients to drive processes, no possibility for complexity or life. The universe would be filled with a thin soup of elementary particles and radiation, all at the same temperature, with no way to organize themselves into more complex structures. This heat death would be the final victory of the second law of thermodynamics, the law that states that entropy always increases. It would be the end not just of life and consciousness, but of the very possibility of interesting events occurring. The universe would have reached a state of maximum entropy, where no more work could be done and no more information could be processed. The timeline for this cosmic death is so vast that it's almost meaningless to contemplate. The heat death would occur after 100 years or more, a time so long that the number of years would have more digits than there are atoms in the observable universe. But it would be inevitable, the final destination of the cosmic journey that began with the Big Bang. Yet even in the face of this ultimate fate, the universe continues to surprise us with its complexity and beauty. The same physical laws that guarantee the eventual heat death also allow for the formation of stars, planets, and life. The same quantum fluctuations that might trigger vacuum collapse also create the diversity and unpredictability that make existence interesting. The cosmic horror that surrounds us is real, but it's also balanced by cosmic wonder. The universe is vast and dangerous and ultimately doomed, but it's also filled with phenomena so strange and beautiful that they challenge our understanding of what's possible. The darkness between stars is not empty. It's filled with the potential for discovery, for understanding, and for moments of transcendent beauty that make the journey worthwhile. As you drift towards sleep tonight, carried by the rhythm of cosmic expansion and the slow dance of galaxies through space, remember that you are part of something magnificent and terrible. You are a temporary pattern in the eternal flux of matter and energy, a brief moment of consciousness in an otherwise unconscious cosmos. The universe may be trying to kill you, but it's also the reason you exist at all. The silence of space is not truly silent. It's filled with the whispers of dying stars, the echoes of cosmic collisions, and the faint background hum of the universe itself. These sounds tell the story of creation and destruction, of the endless cycle of birth and death that governs all existence. They remind us that we are not separate from the cosmos, but part of it. Temporary expressions of the same fundamental forces that shape galaxies and govern the behavior of black holes. In the end, the most terrifying and beautiful truth about the universe is that it's all connected. The carbon in your body was forged in the heart of a dying star. The oxygen you breathe was created in the fusion furnaces of ancient supernova. The iron in your blood was scattered across space by stellar explosions that occurred billions of years ago. You are literally made of stardust, a temporary arrangement of cosmic debris that has somehow learned to think and feel and wonder about its origins. The universe is vast and dark and filled with dangers beyond imagination, but it's also home. It's the only place we have, the only reality we know, the only stage on which the drama of existence can unfold. The cosmic horror that surrounds us is real, but so is the cosmic beauty, the endless creativity of a universe that can create both black holes and butterflies, both gamma-ray bursts and human consciousness. Sleep well, knowing that you are part of this magnificent and terrible cosmic story. Tomorrow, the universe will continue its ancient dance of creation and destruction, and somehow, impossibly, you'll be there to witness it. As you slip deeper into the cosmic embrace of sleep, there's one final truth that demands to be spoken. The universe isn't just vast and violent and indifferent, it's also profoundly lonely. In all our searching, in all our listening to the cosmic radio frequencies, in all our scanning of distant worlds, we've found nothing. No signals from alien civilizations, no evidence of other minds contemplating the same dark sky. Just silence, stretching across billions of light years of empty space. This silence might be the most disturbing discovery of all. It suggests that consciousness, this remarkable ability to think and feel and wonder, might be incredibly rare in the universe. We might be the only beings capable of understanding the cosmic horror that surrounds us, the only witnesses to the magnificent and terrible dance of creation and destruction that plays out across the cosmos. Consider the implications. If we are alone, then every human thought, every work of art, every moment of love and compassion represents something precious beyond measure. We are the universe's only way of knowing itself, the only means by which the cosmos can contemplate its own existence. When we look up at the night sky, we are the universe looking back at itself with wonder and terror. But this uniqueness comes with a crushing responsibility. If consciousness is as rare as it appears, then its preservation becomes the most important task in the universe. Every species that goes extinct, every civilization that collapses, every world that becomes uninhabitable represents an irreplaceable loss. We are not just fighting for our own survival, we are fighting for the survival of awareness itself. The cosmic perspective changes everything. Our petty conflicts, our tribal divisions, our short-term thinking, all of it seems absurd when viewed against the backdrop of cosmic time. We are all passengers on the same tiny spacecraft, hurtling through the darkness of space, surrounded by forces that could destroy us without warning. Our differences are microscopic compared to the vast challenges we face as a species. The universe has given us a brief window of stability, a moment of cosmic calm in which complex life can flourish. But this window is closing. The sun is gradually getting hotter. The galaxy is moving toward its collision with Andromeda, and the expansion of space is accelerating. We have perhaps 1 billion years of good conditions remaining, maybe less. In cosmic terms, this is barely an instant. What will we do with this time? Will we waste it on conflicts and competition? Or will we use it to spread life and consciousness throughout the galaxy? Will we remain trapped on this single world, vulnerable to every cosmic catastrophe? Or will we become a spacefaring species, resilient enough to survive whatever the universe throws at us? The choice is ours, and the clock is ticking. Every moment we delay, every year we spend fighting among ourselves, is a moment lost to the cosmic darkness. The universe will not wait for us to grow up, to overcome our differences, to realize our potential. It will continue its inexorable march toward entropy and death, indifferent to our hopes and dreams. Yet there's something beautiful in this urgency, something that gives meaning to our brief existence. We are not just random arrangements of atoms. We are the universe's attempt to understand itself. We are the cosmic equivalent of neurons in a vast brain, capable of thought and memory and consciousness. Through us, the universe experiences wonder, love, fear, and hope. The darkness of space is not empty, it's full of potential. Every star that forms, every planet that coalesces, every molecule that combines in just the right way represents a chance for something remarkable to emerge. The universe is not just a machine grinding toward heat death. It's a creative force, constantly experimenting with new forms of organization and complexity. We are part of that experiment, perhaps the most successful part we know of. We have learned to harness fire, to split atoms, to decode the genetic instructions of life itself. We have sent machines to other worlds, peered into the hearts of distant galaxies, and begun to understand the fundamental laws that govern reality. We are the universe's way of transcending its own limitations. But with this knowledge comes a terrible awareness of our own mortality. We know that our sun will die, that our galaxy will merge with another, that the universe itself will eventually reach a state of maximum entropy. We are conscious beings living in a cosmos that seems designed for unconsciousness, complex structures existing in a reality that tends towards simplicity. This paradox defines the human condition. We are temporary patterns in an eternal flux, brief moments of awareness in an otherwise unconscious universe. We know that we will die, that our species will eventually go extinct, that everything we build will ultimately crumble to dust. Yet we continue to create, to love, to hope, to dream of a better future. Perhaps this is what makes us human. Not our intelligence or our technology, but our ability to find meaning in the face of meaninglessness, to create beauty in the midst of chaos, to love despite the certainty of loss. We are the universe's way of rebelling against its own nature, of creating islands of order in an ocean of entropy. The cosmic horror that surrounds us is real, but it's balanced by cosmic wonder. The same forces that can destroy us also created us. The same quantum fluctuations that might trigger vacuum collapse also generated the diversity and complexity that make existence interesting. We are children of the stars, born from the ashes of ancient supernova, carrying within us the elements forged in the hearts of dying suns. This knowledge should not terrify us, but inspire us. We are not separate from the cosmos, but part of it, temporary expressions of the same fundamental forces that shape galaxies and govern the behavior of black holes. We are the universe becoming aware of itself, if only for a brief moment in cosmic time. The silence of space is not truly silent. It's filled with the whispers of creation, the echoes of the Big Bang still reverberating through the cosmic microwave background, the gravitational waves from colliding black holes rippling through space-time itself. These sounds tell the story of our origins, of the cosmic processes that led to the formation of atoms, stars, planets, and eventually life. As you drift towards sleep, carried by the rhythm of cosmic expansion and the slow dance of galaxies through space, remember that you are part of something magnificent and terrible. You are a temporary pattern in the eternal flux of matter and energy, a brief moment of consciousness in an otherwise unconscious cosmos. The universe may be trying to kill you, but it's also the reason you exist at all. The darkness between stars is not empty. It's filled with the potential for discovery, for understanding, and for moments of transcendent beauty that make the journey worthwhile. Every photon of starlight that reaches your eyes has traveled for years or centuries or millennia to bring you information about distant worlds. Every breath you take connects you to the atmospheric cycles that have sustained life on Earth for billions of years. You are not just in the universe, you are the universe. You are star stuff contemplating stars, cosmic dust that has learned to think and feel and wonder about its place in the grand scheme of things. The carbon in your body, the oxygen in your lungs, the iron in your blood. All of it was forged in the nuclear furnaces of ancient stars, scattered across space by stellar explosions, and eventually incorporated into the world that gave you life. This cosmic perspective should fill you not with despair, but with awe. You are part of an unbroken chain of causation that stretches back to the beginning of time, a link in the cosmic story that connects the Big Bang to the present moment. You are the universe's way of knowing itself, of experiencing wonder and beauty and love. The cosmic horror that surrounds us is real, but so is the cosmic beauty. The same universe that contains gamma ray bursts and black holes also contains music and poetry and the laughter of children. The same physical laws that guarantee the eventual heat death of the universe also allow for the formation of stars, planets, and life. The same quantum uncertainty that makes the future unpredictable also creates the possibility for novelty, creativity, and surprise. In the end, the most profound truth about the universe is that it's all connected. The light from distant stars, the gravitational pull of the moon, the radioactive decay of atoms in your body, all of it is part of the same cosmic symphony, the same grand narrative of creation and destruction that has been unfolding for nearly 14 billion years. Sleep well, knowing that you are part of this magnificent and terrible cosmic story. Tomorrow, the universe will continue its ancient dance of creation and destruction, and somehow, impossibly, you'll be there to witness it. The darkness that surrounds us is not empty. It's full of possibility, full of wonder, full of the same stardust that makes up your beating heart. The cosmic horror is real, but so is the cosmic miracle of your existence. In a universe that seems designed for unconsciousness, you are aware. In a cosmos that tends toward simplicity, you are complex. In a reality that moves toward death, you are alive. And in the vast darkness of space, you are a brief but brilliant light, a moment of consciousness in an otherwise unconscious cosmos. Rest now, child of the stars. The universe will continue its ancient song, and you are part of its melody. The darkness is vast, but it's also full of light, the light of distant suns, the light of human consciousness, the light of hope itself. In the silence between heartbeats, in the pause between thoughts, the cosmos continues its eternal dance, and somehow, miraculously, you are here to witness it all.